Formatted strings, or fStrings for short, are a great way to format strings in Python. They are simple to use, easy to read and very powerful at the same time. Thanks to them, working with strings in Python is much more convenient than in many other programming languages. Today I will show you how to use fStrings effectively, and together we'll go through the most interesting use cases. My name is Kamil Brzeziński and welcome to my channel. The first question is, why do we even need formatted strings? So let's have a simple sentence. Hi, my name is X and I'm Y years old, where X is the value of variable name and Y is the value of variable age. If you want to create a string like this, we can do it by concatenating text and variables using a plus operator. This solution, however, is not very clear, not very readable, and in this very case it won't even work. When we try to run it, it will result in an error. Yes, we can't use a plus to concatenate the text value and a number. If you want to make it work, first we need to convert an age variable to a string. Of course, it's doable, but that's an extra thing we need to remember about. Okay, so we need a better solution here, a solution that would allow us to put expressions and variables inside a text variable in an easier way. In first versions of Python, programmers use a solution known from other programming languages, most notably from C, so very often this type of string formatting is known as C-style formatting. In this solution, instead of putting name and age variables into a string, we put there a percent operator. A percent operator means that this is the place in a string where we are going to insert an argument. Together with a percent operator comes a specifier, which defines what type of an argument we're going to pass. After the string, we add another percent operator and provide an argument, or if there are more than one, a tuple containing all the arguments. When we only have two variables, it looks quite okay, but what if you had 5 of them, or 10? It will get messy and very inconvenient. We'll need to remember about the proper order of all the arguments, and we'll need to make sure that we use a correct specifier for each one of them. For text values, we'll need to write %s, for an integer it will be %d, and for a float number it will be %f. We can do it much easier, and this is why we don't use this solution anymore. We also don't use a solution that was introduced in Python 2.6, and I'm talking here about the format method that can be called on a string object. This is how it looks, better, but still far from perfect. And here comes the newest solution introduced in Python 3.6. It's called literal string interpolation and it's widely known as fStrings. Is this one perfect? I'll show you some examples in a few moments so you can make up your own mind, but if you ask me, I think that fStrings are just great. We'll start with an already known example with exactly the same sentence, and if we use fStrings, it looks like this. Fstring looks very similar to a regular string. We can have double quotes here, we can have single quotes, but then of course we need to escape this one. The only difference we can see here is that f in front of a string. This f indicates that this is going to be fString. And if we want to insert a variable inside an fString, we put its name in curly braces. And that's all. We can now run this. And we can see that these two variables, name and age, were inserted into a string. But fStrings allow us to do much more than just to insert variables inside a string. Let's say that we want to print this name, Kamil, in capital letters. There is a method called upper. This is the method we can call on a string, and we can do it directly in the fString. So let's call it like this, name.upper. Let's run it, and we can see that we have now capital letters here. We can also call functions we define in a script. So let me define a simple function here, like print text. It takes nothing and it returns 3 exclamation points. And we can just put it here at the beginning of our fString. Of course, we didn't call it, so let's do like this. And here it is. So we call the function directly from fString. Using fStrings, we can also do arithmetic operations. So let's define a new variable. I will call it a number, and I will assign 2. And now print f number. Let's run it. Of course, now we have 2. but we can now multiply number by 2. And let's run it again. And now we have 4. And what about formatting float numbers? Let's change it to 21.5. Now we will display it like this, 21.5. But sometimes we want to display a given number of digits in a fractional part. We can do it very, very easily using fStrings. So we put a colon here, now a dot, and now we give this number. So let's say that I want to display 2 digits. 2f, and now we have 2 digits. If we wanted to have 5 digits, we should change 2 to 5, and now we have 5 digits in a fractional part. fStrings are also very helpful when we want to format currencies. Let's say that we have a great amount of money, 1, 2, 3, 4, 5, 6, 7, and if we want to display as a currency, we could make it easier to read by using commas. So it would be like this, 4, 5, 6, 7, and putting commas here. We can of course automate this using fStrings. We do it like this. So I'm removing 5f, I'm removing this dot, and I'm putting comma here, and Python knows already what we want to display. And it displays like this. And now different numeric notations. In programming, sometimes we need to display a number in binary notation, octal or hexadecimal one. And yes, fStrings allow us to do it in a very easy way. So let's change this number to something smaller like 300. And now let's say that we want to display it in a binary notation. So instead of comma, I'm putting B here, and here it is, 300 displayed in a binary notation. Let's see octal here. I'm changing B to O. Here it is. And now hexadecimal, it's either X or capital X. We can also, in a very easy way, display a corresponding character from the ASCII table. So let's change 300 to 65. And now I want to display a character from the ASCII table that is under 65. I'm putting C here, it means ASCII, and we should see a capital A. And here it is. To make sure that it's correct, let's look at the ASCII table on asciitable.com, and indeed we can see that 65 is capital A. So if we change 65 to 64, we should see an add character. Let's check it. 65 to 64, and here it is. We formatted text, we formatted numbers. What about formatting dates? Let's take a look. First, I will import a datetime library, and I will declare a new variable called now, and it will be datetime now. It will return the current time. Let's print it to see how it looks. This is the current time, it's not formatted, and now using fstring we can format it in any way we want. So let's do it. F, it will be now without formatting. We can see that they both look the same, and now we can add this formatting. So now colon and %y, it will be year. Now %m, it will be month, and %d, it will be day. If you also wanted to display hour and minute, it will be h and a capital M. Now I will show you how you can use fstrings to display data in a cleaner way. I created a very simple dictionary here, names and salaries. So here we have several names and salaries. And we go through the whole dictionary and we display name and corresponding salary. Very easy, Camille, Tom, Rob, and their salaries. It looks quite okay, but what if we had another name here, like a very, very long name? And let's say it's 10,000. I'm running it again, and we can see that it doesn't look very clear anymore. We have this very long name it doesn't match the other names. We can make it much better using fStrings. So let's start with changing this into an fString, name, salary, and let's run it again. It should look exactly the same, and it does. And now we can tell Python how wide we want to have our variable, because now it takes as many space as many characters we have. But we can do something like this, and now we tell Python that we want a name to always take 30 characters. Let's run it, and we can see how it works. So now it always takes those 30 characters. Another cool feature is shifting strings by a defined number of characters. So let's go back to the first example. Name Camille, age 33, and I will create fStrings name and age. Let's run it. They were displayed like we expected, no shifting here. But we can shift this one by 10, and we can shift this one by 5. We can now see that they were both shifted to the right. fStrings might also be very helpful when we debug our applications. It's very common that we print out some variables when we debug. So we usually do something like this, name, age, and we see the values of those variables. Here we only have two variables, so everything is clear. But if we have longer scripts, if we have more variables, it might become messy. We might get lost in all those variables. Then we can just use a very simple trick. If we have an fString, just add to the variable name an equal sign, like this. And the result is like this. Not only the value of a variable is printed, but also its name. And what about multiline strings? If we have a multiline string, a regular one, we do it like this. So we have triple quotes, and we can put a name here, 33. We can put hello here. We can add some spaces. And now when we print it out, the whole formatting is preserved. How does it work with fStrings? Let's check it. So I'm putting, instead of Camille, I'm putting name here, I'm putting age here, and adding f at the very beginning, and it still works. This is all for today. Thanks for watching, and have a good one.